Ensuring safe physical human-robot interaction remains a challenge. Our system combines a single-piece inflatable envelope with 16 distributed TOF sensor modules, covering the full humanoid body at 20 Hz. Sensor readings are filtered and aggregated in real time into a unified point cloud across the entire surface. To train the model, the robot randomly explored its joint space, collecting point cloud data over 20 minutes of motion. An MLP predicts the contact-free skin surface from joint angles. Deviations from this prediction, confirmed by DB-scan clustering, indicate genuine contact. The system is validated across diverse physical human-robot interaction scenarios, from single-point contact to full-body hugging. Moreover, the robot can interpret not only where contact occurs, but also what it means and how it changes over time, such as when a hug begins and ends. By combining inflatable skin, TOF sensing, and learning-based detection, our system enables scalable, safe, and contact-rich whole-body interaction.